right, hi everybody. Thank you all for coming and coming back from the coffee break. That might have helped that they ran out of cookies, but you know, we're all here to talk a little bit about transfer learning. And I really intend this to be a little bit high level. I know that there are people of all kinds of different technical levels in the audience, but you know, we're not going to get into all of the nitty gritty, but at the end I'm going to put up a bunch of different resources and walk through where you can get a bunch of tutorials that will teach you how to actually do some of this stuff. But a lot of what we're focusing on is, hey, what is transfer learning? How is it helpful? And how can it be applied to various different things today? So as Priya said, I'm Catherine Havasi. I've been working in natural language processing for a really long time, so no matter how much I try, I'm going to veer into natural language processing all the time, even though I am going to cover other areas, self-driving cars, images, video, that kind of stuff. But you know, I'm always going to end up back in language because I love language, and that's just what happens. So we're going to talk a little bit about transfer learning and why it's important for language. So for quite a while, it's really been everyone's dream to talk to computers, and I love giving talks in environments where people actually remember, unlike in academia, you know, this movie and things like that. But it's really something that's increasingly part of what companies need to do, what brands need to do, is really understand people when they talk. And one of the reasons for this is because we're becoming more conversant, right? We want to talk naturally to systems. We want to talk naturally to everything from IVR systems to search boxes to our phones. And doing that requires natural language understanding. And sort of a theme for today, and probably some of the talks you've been to so far, is that real natural conversation, and the way people talk is hard. It's full of all kinds of jargon, it's full of slang, it's full of emojis, it's full of all that kind of stuff, and that's going to be a problem. So things have gotten much better recently, right? So probably a bunch of people here know there have really been huge advances in natural language processing. You know, we started out with this thing that was basically keyword matching and writing little if-then rules, and then we built these big, huge trees, and I've done it, of, you know, how different words are related to different other words. And then from there, we went sort of to unsupervised machine learning, where, you know, we learned that certain things were associated more often with other things. And these days, we've moved into something called word embeddings, which is really a form of doing deep learning for NLP. And everybody has gotten very excited about deep learning. We've really seen that automation has a lot of power that can be brought to many different business problems. And for those of you who haven't gotten a working definition yet at this conference and are really frustrated, you can just think of deep learning as focusing on finding patterns in input data at a sophistication and scale that really hasn't been done before, and bringing those patterns up and applying them in all kinds of interesting different ways. So it's really about finding and understanding patterns. And in its native form, that's great. It also has some problems. We'll get there in a second. So in about 2013, something called Word2Vec came out. Most of you, or some of you, probably know what that is. Word2Vec is a type of machine learning that built what's called a word embedding, or a vector representation of word meanings, out of a lot of distributional information about how different words related to each other and how they showed up in text. And we wanted to apply that to natural language understanding. There was this well covered in the popular press example that man is to woman as king is to queen. Everybody talked about analogies being a great metaphor for the way language worked. And that really brought to light a field of doing vector work on text that had been going on for some time. And I think really brought up a lot of questions about whether or not that could help language understanding. So language understanding is one place where this is a real big issue, but it's an issue other places, which is that training something like Word2Vec requires a lot of data. So to build Word2Vec, we're really looking at, you know, the data on the web, right? And in most cases, for most domains or specific types of text, you don't have that kind of data. So it takes something like hundreds of millions or billions of points to train something like fast text or GloVe or Word2Vec or your other deep models. It's really a lot of data. And if you're thinking about it, that can be a problem, right? So in a lot of places, we can kind of get around that problem by either creating synthetic data or by having systems really learn by playing themselves. You know, in order to beat a human player at chess, AlphaZero really had to play itself about 68 million times. We'll get into why that's a problem for text. You can probably guess that's a lot of data that's not there. And the reason why that happens is because each time we really need to learn from scratch everything that we know before we do anything else. And that's really not how people work. So a great quote to sort of exemplify that is from OpenAI. But really what we're saying is that, in a sense, people can generalize from what we know. So if we're out there and we're playing a game like chess, we can bring in a lot of ideas and examples and things, even if we're bad at chess like me, from other games and other areas that we can bring to bear on strategy, on even things basically like turn taking and how it works. And we need to build systems that generalize. And so that's sort of the principle behind transfer learning, is can we take things we learned in one domain or in a general world and make them work across a couple other domains. So transfer learning and domain adaptation are very related. Transfer learning means we're taking something that was meant to do one thing and we're moving it into another domain. Domain adaptation is specifically the version of that where you're taking a very general system, like a general image classification system, and making it work for doing something like labeling, figuring out labels of cans for grocery stores, or for doing robotics and automatic shelf stocking and all that kind of stuff. So really what we're doing is we're trying to take stuff that we learned in one domain and move it into another domain. The motivation for doing this is because frequently there isn't enough data in the target domain, or because you can't simulate data. For example, one of the reasons we're doing this in robotics is because if you want to say, there's a problem called robot picking, which is basically that if I have a robotic arm, I need to be able to pick something out of a bin and put it in an Amazon box, right? And Amazon has spent a lot of money and time on this problem, but you can't really create simulated data for it. It doesn't work, much like language. And fortunately or unfortunately, if you keep, people have built farms full of robotic arms that have tried to pick things up and move them repeatedly to create big enough corpora. They're still not big enough. And so you still have to come up with a different way of doing things, moving into domains. And so that is essentially what we're trying to do. I think that transfer learning is considered something really new. I've been working on it for a long time. It's really gratifying to hear other people talk about it. It's really gratifying to hear a lot of people in ML really pick up on this. The slide I didn't put in here is sort of the increase in Google searches for it recently, which is really exciting. So you probably all run into transfer learning whether or not you know what it is. So transfer learning is really what makes your selfie or your picture of your dog be able to look like Picasso or any of those other artists, all these filters that you see. So that's something called style transfer, which is really taking a picture that you've taken, understanding what it looks like, and transferring it into the domain of things that have been made by this other artist. And so that's a really good accessible example if I still confused you up until this point. So transfer learning is often really, if you're on the internet, you'll run into all kinds of different style transfer things that are really quite fun. So it's very popular on making sort of fun machine learning examples. This is a great one done by Chris Lordley of what would happen if you took a book of dinosaurs and a book of flowers and transferred one into the other, and then you end up with dinosaurs made out of flowers. So these have all been really fluffy examples. I want to give some examples that are a little bit more practical. So self-driving cars. So it's really difficult to go out there and get all kinds of data that you need for doing self-driving cars. And one of the reasons for that is because you need data for difficult or dangerous situations. And you don't want to put self-driving cars in difficult and dangerous real-world situations frequently to deal with this. And so there are a lot of different ways of handling that. And one of the things that's been worked on recently by a number of different large automotive companies is actually using transfer learning to do this. So what they're doing is they're building essentially toy domains and building a mechanism from transferring to the toy domain to the real domain. Except the toy domain is frequently sort of a model robot car or a simulation where you can try out all kinds of different things and then move them into the real domain to try to see, well, can we build something that would cause the car to react in a better way in a difficult environment? So if anybody ever, when you were younger, played a lot of Microsoft Flight Simulator and was trying to test yourself by turning off all different kinds of things in the cockpit and trying to land the plane anyway, that's essentially what you can do for autonomous vehicles using transfer learning. And one of my favorite examples is low-resourced languages. So anyone who's done any natural language processing that's global out there knows that there are certain languages like English for which there's every resource in the world, and certain languages like, say, Finnish, for which there are absolutely no resources available for you to train or test or build things. And so a lot of work right now has been done in saying, how can we use transfer learning to take data from high resource languages like English and move them into lower resource languages? I'll get into some of that in a bit. And those are all places that, and some of that's been used to do everything from sort of language preservation work down to more practical things that are actually helpful for the enterprise. And we've really started to see a lot of transfer learning in video and voice in sometimes very scary ways. Many people have seen demos on YouTube of someone trying to make a public figure say one thing or another by transferring across your particular face and the public figure's face. And some of that work raises a lot of questions about what we can do with transfer learning, especially style transfer into different people's voices. So to sort of end out the general section, one of the things I wanted to do is sort of highlight here what kinds of things you're actually getting from transfer learning. Don't have a, oh, that's not good. Okay, great. If we see up here, what we're doing here is we're requiring less data overall to get started, and we're ending up at a place that tends to be more accurate with transfer learning. So it's really great when you don't have all the data in the world, which is most enterprise cases, and really getting starting earlier and getting up to that high accuracy level very quickly. So this is a real world example of that graph. This is a really simple task of Amazon Book Review classification and prediction of ratings. The bottom two are fast text with different data sizes and Robo Rabbit. The top one is what my company does. So we do natural language understanding with transfer learning into domains for customer service optimization and automation. And so this is kind of an easy task for us, but we're in here predicting outcomes of book reviews using transfer learning into that domain, and we're not using any additional labeled examples. So we have no labeled examples. And we're still improving in accuracy. So it's the same type of curve that you're going to see. So you really do see that in real life. So that's great. We've talked a lot about self-driving cars and Picasso dogs and silly videos where you're pretending to be Donald Trump. But really, how does that work in practice for business? And sort of the theme of this track is taking some of these big ideas in AI and saying, how do they apply to the enterprise specifically? So let's take a look at that in practice. Again, going back, the big issue here is that enterprises don't have the kind of data that we are looking for, right? So if we want to train a big model, it often takes hundreds of millions or billions of data points. People don't have that. So what we can do is start out with a general model and work down from it. Let's talk about text specifically for that. So let's talk about text in particular domains. There's often really good examples given of why domain specificity is really important for text. Let's talk about mobile interfaces, for example. If a hamburger and a carousel are both parts of a mobile interface, but they mean very different things to, say, a travel company who's looking at doing recommendations for where you should visit on your trip. Stickiness is great for software sales and terrible for lipstick. Transparency is really good in governance, corporate governance, but really isn't something you want in clothing unless you really intended it. And so language is one of those things that can be very, very domain specific. And sometimes there's not really a lot of data. One of the places I started out working was doing on this, doing market research work for a lot of organizations. And we did a lot of work with 2 or 3 big chocolate companies. And one of the things that's really interesting is trying to bring computational analysis to chocolate design and chocolate tasting. If you think about it, what ends up happening when a new chocolate bar goes out in the market, or there's now Kit Kat dark chocolate with white chocolate filling, or whatever is going on, they have expert chocolate tasters taste those, talk about tasting notes, things like that, and then they go out in the street and they get individuals to taste those as well. The language that's created for expert chocolate tasters across every company in the world, for every chocolate bar that's out there, is probably not enough to ever train a deep learning system on chocolate. It's just not enough text that's out there. And it can be very unique words. You can think about, I'm sure they have the same, in fact, I know they have the same types of words that you have for doing wine or other sorts of tasting. And so that sort of exemplifies the issue. And this gets much worse for really jargon-heavy fields: financial services, healthcare, consumer electronics. Any field that has a lot of different product names is always one of those fun ones. And anywhere where there's a lot of ever-changing slang, say news or politics or any of those places. So that really becomes a problem. And so really when you're thinking about that, you think, well, okay, what do we need to make transfer learning succeed? Clearly, we need it in this kind of business case to be able to actually get results in being able to apply this kind of machine learning with corporate text or even image recognition. So one of the big guides here is that transfer learning really works well if the features of the first model that you start with are very general. And so that means we want to build a really good idea of, say, what things in the world look like in general across a wide swath of things. We want to build a really good interconnected model of that. For language, we want to build something that looks a little bit like a really good distributional model, plus a lot of information that connects it together and really makes it robust and understand basic stuff about the world. So we add in common sense reasoning. We distribute that base model as concept net number batch, and I'll talk about that in a second. But it's really, the key here is to really make something good and general, put in information that really just knits things together, but you don't expect to be relevant to the domain. So that's because a lot of analogies are made to more complicated concepts, are understood by simpler concepts, so you can think about that in model building as well. So a great example of this is in industrial regulation and industrial testing. So if you think about it and you take a regular sort of Inception style Google deep learning algorithm and you say, find me all the cracks in the factory that's being built here that could possibly be an issue from the photographs that were taken by a drone. Not going to happen, right? And there's probably not enough data from that to ever train a model from scratch. And if you used a domain general model, what you would end up with is a model that's made to sell advertising and is really good at figuring out where cats are, right? And so that's not going to actually help you find any cracks in your facility. So what you need to be able to do is take a really robust domain general model, maybe even one with cats in it, use some domain specific information and move it over. Another great example of a domain general model I mentioned is ConceptNet. So we, like fast text or Word2Vec, put out something called ConceptNet Number Batch, which is an interconnected model of about 70 different languages. OpenMind or ConceptNet is a big open data project. We love going to ODSC. You can download it at conceptnet.io. It's a big open data model, and it's a great base for being able to do this kind of thing because the text we use is not just distributional semantics, but also includes something called common sense. And what that is information that coffee comes in mugs and people want to be respected, and that sort of knits together the space in a way that's really helpful for being able to transfer into and out of. And a way of really explaining that is with a couple of different case studies. So my favorite domain-specific language is gaming. So it's a really fun and funny domain. It looks a little bit like the real world depending on the game, and then it deviates wildly other places. It can look exactly like our world, and then we can have wizards who throw spells and buy crystals and all kinds of other things. So that becomes a really interesting domain to transfer into. And so when Luminoso, as I said, does automation and optimization for customer feedback analytics, so one of the things that we're supposed to do here is help this gaming company be able to take their customer service workflow, automate more of it, and be able to optimize the way they respond to different things. And I'll explain how that works. So they have a lot of different, very specific language to these games, and that updates a lot. And so what you need is to be able to build something that's a model that's very domain specific, but also updates. And so their ideal world and what they have through our product is basically when a customer service ticket comes in, it looks at it, it says, okay, is this person, given what they're asking for, more likely to go self-help? In a lot of mobile gaming, people often write customer service forums and ask for free stuff, right? Because it's all this pay-to-play gaming. It's like, oh, well, maybe if I complain to customer support, they'll give me a free thing to make me go away. That actually never works. So there are many different ways to ask for free things, and you can't really predict ahead of time what they're going to be. So you need a system that's constantly learning that domain to be able to push that there. For these folks, we were able to give them something that sent about 40% more stuff to self-service in a way that automatically learned to their domain without needing to code in what ice wizards were and all that kind of stuff, which was really nice. And then was able to transfer to the right representative with about 10% more accuracy than what they were using. And so the third part of it is also how it lines up with Scrum or sort of agile environments. Given that a whole bunch of different stuff that comes into this particular gaming company, they'll put out something like, it'll have a new product with a new woodcutter you can buy, and maybe the woodcutter is broken. And what you need to know very quickly is what's broken and what you want to fix before the game rolls out across different places. So being able to categorize and say most of the issues are around things like the woodcutter, and this is what woodcutter means in this domain, and that we want to elevate that bug becomes very important. I have a couple different resources here for actually learning how to do the programming side of this, sort of in order of technical difficulty here. So if you're interested in doing more of this, if you're interested in actually writing some code, these are all great places to start. I'm probably going to make the slides available somewhere here. If you look at the citations at the bottom of things, you'll also find some academic places to start looking around into this, although a lot of things like our algorithm aren't public, and that's sort of the issue in NLP transfer learning, is a lot of the best algorithms are proprietary still. If you want a great open vector space, open data vector space for doing language, domain general, or domain specific, please come and find us. We're in almost 70 languages, including all the hard ones. And this is actually the oldest AI crowdsourcing project. We started in 1999, building models from bored people on the internet, as we called it before the name came out there. And so we're still one of the biggest, so come find our vectors. And thank you. If you have more questions, I know I'm out of time. We do have time for questions? Great, we have time for questions. So I'll take some questions here and then I'll be out there afterwards. All right, thank you. Yeah.
So how do you say, like, gaming prioritize practicing? Is it the language that the gamers speak? Is it the language of the game? What aspect of it and how you process it is prioritizing?
So I guess the question was, how do you deal with differences in language from sort of different stakeholders, and specifically in the gaming example, people who make the game and people who play the game. In gaming, people tend to use the same thing. A great example where they don't is taxes, right? So basically, people who are writing FAQs for doing your taxes do not use the same language as people who are asking questions about taxes. And people who are asking questions about taxes have wide varieties of different difficulties in the language that they speak. What we do is we actually have both in the same model. And so the computer is learning the jargon as well as how the jargon lines up with sort of the colloquial speech. And so it can think of those things as synonyms. So I can see reasons why you'd want to build an expert model and a person on the street model, same for the chocolate example, and sort of transfer between the two of them, but I think that's going to add extra complications. You know, for the more technical people out there, I'm one of those people who really thinks that you want to throw everything in the same vector space anyway and let the math sort it out, and that's tended to work very well in the work that we've done. Yes?
Have any use cases around
News data. There's a bunch of different types of things you can do in news data. My favorite use case that I did here as an ODSC talk a little while ago, a couple years ago, was we did the analytics in the app for the 2014 World Cup. And so that was all the news that was coming in through all the social channels as well as different things. And I think the big thing there was trying to do, and this is more real-time analytics, how do we update these models in real time in order to be able to react to things that are happening in the game. And I guess with those, the transfer learning is really the first step of it, because once you personalize to that, what you're really doing is adding new vocabulary as it comes up. So I have all kinds of, honestly, really hilarious stories around that. My favorite one is watching the Dutch team. There was a point in the 2014 World Cup, which people probably don't remember unless you were watching this particular game at this point, where somebody did this crazy header and scored a goal for the Dutch team. And after that, that player was named the Flying Dutchman. So for real-time news, you need to actually learn that there are a couple really happy people in the audience right now. The Flying Dutchman was this particular player. Map it to that, and then when people say, hey, I want to know more about the Flying Dutchman in my newsfeed, in my little custom newsfeed in the app, you get that there. So it's all, usually with news, it's all about categorization or doing sort of product discovery work. But I can definitely see, we don't do it, but there's definitely a lot that would happen with transfer learning on both news images and biotech type news. Person in the back, yeah. I can't hear you, I'm really sorry.
when you learn representations for entities in language models,
Yep.
do you train it on a particular task? Because then you run into the risk of throwing away pieces of information that's not valuable, or do you just do straight up dimensional reduction?
So there's concepts and then there's entities. So for concepts, we're doing a lot of work trying to figure out what concepts are salient in a particular domain. When we keep them, that's a combination of what concepts that we have in our base model and what concepts we find in text. When it comes to named entities, there's a lot like actual entities like your name is John Smith. There is a lot of interesting work being done right now in various deep models for named entities. I don't ever actually work with that because all of my data is internal to companies. And these days, because of privacy, all of that is stripped out before I see it. So I don't want to find the names, right? I'm not looking for that. I'm looking to make sure that the right person gets to the right place, not that any of this is PII. And you know, we're days from GDPR, so everything gets more and more like that every day. So really when you're working with public data is when you care about names, and when you're working with private data, you really hope you don't see them. Yeah?
If I heard you right, you said that transfer learning works best if the model can start with this thing at zero.
If you can, yeah.
Right.
It's not always possible, but yeah.
But in the natural language space, are people only general purpose model? Like where do you
Yep.
stop?
Yeah. So general purpose model is right here. So we have a general purpose model. Facebook has a good general purpose model or good toolkit for building general purpose models called fast text. You can run it on all kinds of different things. Google has one called Word2Vec, which is actually, I think, deprecated by Google at this point, but is still really widely used. There's a couple very amused people by that. And I would also recommend Glove by Stanford, but try to get one that's fixed. There are a couple issues with some of the open models, especially Glove and Word2Vec, especially around race and sex biases in the models. I gave the man is to woman as king is to queen example, but if you do man is to woman as programmer is, it will tell you homemaker in the Google model. So I really advise trying to look at, Microsoft has done a lot of work in debiasing, we've done work in debiasing, our embeddings are debiased. But this is just my personal thing, try to find something that fixes that kind of issue. And there's been a lot of great work, and I can't think of it off the top of my head in looking at racial biases in Glove as well. So there are a lot of good spaces out there. There are a lot of spaces out there that will get you what you want faster and might have some problems as well. All right, so we are out of time. I know there are other questions. I'm going to go out in the hall afterwards. I would love to talk to you about any of these things. All right, thank you.